Behavior of materials. Stress, strain, elasticity, plasticity, brittleness. Safety factors. Selecting appropriate materials. 123. Stress. Internal forces developed within a structure due to action of external forces. Stress is force intensity. Force per unit area. Similar to internal pressure. 223. Change in size or shape of element to original size or shape. Strain. Response to stress. Have stress greater than get strain. Strain to do with change in size or shape. Ratio of change in size or shape of element to original size or shape. 323. Strain, cont. 1, DLE equals L for member subject to simple tensile force. Increase in length. Original length. Dimensionless, millimeters, millimeter. 423. Strain, cont. 2, except for rubber bands, strains very small. Usually not visible. More a material strains under load, more the structure deflects. 523. Stress and strain summary. Force, stress, strain, deformation causes. Puts material under deformation. Results in. 623. Behavior of materials. How materials respond to stress, i.e. how they strain. Determined by whether they are elastic or plastic. Properties of materials only explicable in terms of internal forces in the material at the molecular or atomic level. 723. Elasticity. Until you damage the molecular structure, the material remains elastic. It recovers when the load is removed. The spring in a weighing scale deforms in proportion to the load, and returns to zero when you step off. 823. Modulus of elasticity within elastic runge. Stress is proportional to strain. Strain. Stress. A. Linear relationship, Hooke's law. The modulus of elasticity, E, is a property of a material. E equals stress. Strain. E is stress divided by strain. Slope of line, tan A. Same units as stress, MPa. 923. Modulus of elasticity, cont. The modulus of elasticity, E, is a property of a material. Steel 2 lakh megapascals. Modulus of elasticity, E. Aluminium 70,000 megapascals. Concrete 25,000 megapascals, varies. Timber 10,000 megapascals, varies a lot. Steel bar 1 meter long under stress of 150 megapascals. Extends 0.75 millimeters. Too small to see by eye, measured by micrometer. 1023. Modulus of elasticity, cont. The modulus of elasticity, E, is a property of a material. Measures the resistance to deformation. Higher E, more resistant to deformation. 1124. Ductility, plasticity. As long as atomic bonds unbroken, material remains elastic and recovers original size and shape. When break atomic bonds, material fails in one of two ways: plastic, ductile, or brittle. In ductile material, material deforms permanently. Material can be greatly bent and reshaped, plasticine. No loss in strength. Eventually fracture occurs, but after lot of energy. 1224. Ductility, plasticity, cont. 1. Yield stress. Yield point. Elastic. Runge. Stress. Strain. Ultimate. Failure. Plastic. Runge. Ultimate deformation of plastic material much greater. than elastic deformation, visible to naked eye. 1324. Ductility, plasticity, cont 2. Ductility, able to deform permanently prior to fracture. Most materials ductile at low stresses. Most metals ductile, not cast iron. Need also strength. Wrought iron highly ductile but not very strong. High carbon steel very strong but less ductile. 1424. Elasto, plastic materials. Ductile materials can be used safely. Below the yield stress. Overstress, greater than deform dramatically. But don't immediately break. Good warning. 1524. Snap. Brittleness, sudden breaking of atomic bonds. Material fails suddenly, like glass. 1624. Brittleness, cont, stress-strain. Brittle failure occurs with yield point. Stress. Strain. Brittle failure occurs with little energy absorption. Failure. Stone, brick, concrete, glass. High compressive strength. Poor tensile strength. Most traditional structures designed to eliminate tensile stresses, domes, vaults. Timber not durable, 19 THC iron dense steel. 1724. Cure for brittleness, reinforced concrete invented in second half of 19 THC. Steel bars placed in parts of concrete that are in tension. Concrete cracks but steel resists the tension. Cracks very fine, important that water does not reach steel. 1824. Cure for brittleness, cont. Add elastoplastic material that can resist tension into brittle material. 1924. Selecting the right material. Timber, not fireproof. Strength per volume just less than R.C, much less than steel. Strength per weight not much less than steel, long span glulam. Stone rarely used today as structural material. Brick and block, load-bearing walls. For multi-story buildings of medium height. Steel, needs fireproofing, rust-proofing. Reinforced concrete, RC, slow construction. Pre-stressed concrete, PC, expensive. Aluminium, lightweight, expensive. 2024. Safety factors must ensure that structures do not collapse. Must have a margin of safety. Factor of safety allows for imperfections in materials. Loads not considered. Slightly undersized members. Simplifications in assumptions made in analysis. 2 philosophies. Ultimate strength method. Elastic method. 2124. Ultimate strength method. Safety factors. Ultimate strength method. Load that structure carries X, a factor of safety. Factored load called the ultimate load. Factor of safety must be greater than 1.0. 1.0 would mean that structure collapses as soon as service load put on. Factors of safety for buildings vary from 1.5 to 2.5. Depends on structure and material. 2224. Safety factors, elastic method. Ensure that actual maximum stress in structure less than maximum permissible stress. Max permissible stress equals ultimate stress. Factor of safety. Maximum permissible stress nearly always falls within elastic Runge of material. 2324.